Hey, what's up YouTube? Today we're going to be talking about tangent line approximations in our next installment of single variable calculus. So, tangent line approximations are when you have a curve, and we don't know where curves very well. So let's say this is a 3, right? And we know what this value is. And we want to approximate what the value of this function is at 3.1. So I'm sorry if that's like sloppy. What we do is we estimate using a tangent line. So when we have this tangent line, what we're going to do is we're going to estimate the value of this part over here using this tangent line approximation. Now, being that that's the case, it'll be a little bit off, but it's very close to the real value. So let me show you the derivation for how we get to the tangent line and how we're going to apply it into actual problems. So we're going to start off with the slope formula. The slope m is equal to y minus y1, right, the change in y, over x minus x1, the change in x. So being that that's the case, we know that the slope for the for curves, right, at a specific point is going to be dx over dy. Now, y1 and x1 are the actual values. So if this would be 3, that would be x1, and then whatever value y is, this would be y1. And then obviously y and x are the variables. Those could mean anything. We have to plug those in to get an output, right? We still want a function. So let's rewrite this. So we have y minus y1. We're going to ignore the slope part now because now we have the actual slope being the derivative. Dx over dy multiplied by x minus x1. And now the last thing you have to remember about this is just bringing over the y1 to the other side. So we're going to have y is equal to this is dy, my bad. And this should also be, should be dy over dx. It's my mistake. So we have dy over dx multiplied by the quantity of x minus x1 plus y1. So let's take the example of, so on a test, on your AP test or whatever, you're probably going to get something like estimate the value of 9.1, radical 9.1. Like, what is the actual value of this? So we know that this is very close to radical 9, and we know that radical 9 is equal to 3. So the x value for the function y equals radical x is 9, and then the y value is 3. So we're going to use this as y1 and x1. And now, if the general function that we're using is radical x, then the derivative of radical x with respect to x is going to be using the power rule, 1 over 2 radical x. So, now let's plug that in. So y equals 1 over 2 radical x. And this x over here is just going to be x1 because the slope at this is going to be the slope at the at this point at 0.9. So we can approximate 9.1. Then we multiply by 9.1 minus 9 because that's x1. We don't know what y1, well, I mean x2. We don't know what y2 is or the y value yet. And then we're going to add y1, which is 3. So we have that y is equal to, now 1 over 2 times radical x, radical 9 is 3, so you have 1 over 6, multiplied by 0.1, or 1 over 10, plus 3, which is equal to 3 plus, so 1 over 10 times 1 over 6 is 1 over 60, and then 1 over 60 in decimal form, I'm just going to use a calculator to do this, which you can see right here, is going to be 0.016 repeating. So we have 3.016 repeating. Now we're going to see that this is very close to the actual value of radical 9.1. So let's pull up our calculator on Google, just so you can get a value, just to see how close it is. And as you can see, it starts to deviate over here. But the tangent line approximation gets us that far. So This is our final answer. Remember, this is an approximation, not the real answer. And that's how you use your tangent line approximations on the test and what they expect you to do. They probably round this off to 3.02, but that would be your final answer. I hope you enjoyed this video. Thank you for watching. Please give it a thumbs up and subscribe, and I'll see you tomorrow.